So in this video, I will do part two of integral tests. So yeah, this is part two. So let's start with number 13. So number 13, we have the integral of cosine of 1 over y all over y squared of dy. So what should I do? Should I use u substitution? Maybe. But before I do that, maybe I can rewrite this integration problem. This y squared could also be expressed as 1 over y squared times by cosine of 1 over y dy. Okay, so that makes it much easier. Now we may use u substitution. And what do you think my u should be? Yes, I agree. 1 over y. Because if you take the du, what's the derivative? What is the derivative of 1 over y? Well, that's the same thing as y to the negative 1. And the derivative of that is power rule, which is negative 1 y and then old power minus 1. So negative 1 minus 1 is negative 2. So that simplifies as negative 1 over y squared dy. Uh, is there something we need to get rid of? Yes, we need to get rid of this negative because we don't have a negative. So if you want, you can multiply both sides by negative 1. Okay. So that works out. So it's going to be cosine, and then you're going to replace 1 over y with u. And then you may replace 1 over y squared and dy with negative du. Okay. And then what you're going to do next is you see this minus right here? That's like an invisible negative 1, so we could take that out, put it in front. And then what's the integration of cosine of u? Negative sine of u plus c. And why do we have to put a plus c? Because we don't have any boundaries. So my final answer is going to be negative sin, and then you're going to replace u with 1 over y plus c. Okay, that is your final answer. Okay, let's move on to 14. We have the integration of d of x over x times square root of ln of x. What do you think we should do? Yes, I think we should also do u substitution for this one, but just like the other one, let's rewrite this. Let's rewrite this integration problem. This can also be expressed as this is like an invisible one, so you could say 1 over x times 1 over square root of ln of x dx. Right, so that's what I did. I rewrote this. And now we may use u substitution. What do you think the most appropriate u substitution would be? I think it would be, I don't think it's going to be 1 over x, but I think our u should be just regular ln of x. Okay? Because when you take the du, you get 1 over x dx, right? So it works out real nice. So it's going to be 1 over and then square root of ln of x, which is u. And then you may replace 1 over x dx with du. Or you could put the du here, it's fine. Now, how do you take the integration of 1 over square root of u? Well, let's write it as a power. So I know that the square root of u is just u to the 1/2. But I don't want it here, I want it on the top, so I'm going to rewrite this as a negative power exponent u to the negative 1/2 du. Okay, Now go ahead and take the integration of this. What's the integration of u to the negative 1? It's going to be u whole power plus 1, 2 over 2, which is u to the 1/2, and then divided by 1/2. Complex fraction, and if you simplify this, you get 2u to the 1/2, which is really the same thing as 2 square root of u, right? So this simplifies as 2 square root of u, and then don't forget the plus c. And then you can replace your u with ln of x. Okay, that's your final answer. Let's move on to 15. So let's say we have the integration. Now we have boundaries, so we can no longer put a plus c. Our lower boundary is 0, and our upper boundary is positive 1/2. And we have sin inverse of x over square root of 1 minus x squared of d of x. I don't think I'm going to rewrite this. I'm just going to leave it as it is. And I think we're going to have to do u substitution. And what do you think my u should be? Yes, I also believe it should be sine inverse of x. Because when you take the derivative of that, or du, the derivative of sine inverse of x is 1 over square root of 1 minus x squared dx. Okay, so this is going to be 0 to 1/2, and then you can replace the sin inverse with u, and then this is like an invisible one. You can replace this 1 over square root of 1 minus x squared dx with du. Now this is pretty simple right now. What's the integration of u? Well, this has a power 1, so it's going to be 1/2 u squared. Now you could replace u with sin inverse and then do the upper and the lower, or what you could do is substitute when x is 0 and when x is 1/2 into u. So that's what I'm going to do. So when x equals 0, what is my new u going to be? It's going to be sin inverse of 0, which is still 0. And what about when x equals 1/2? Our u is going to be sin inverse of 1/2. And we know that's pi over 6, or you can also write it as a degree, 30 degrees. Okay? So instead of replacing my u with sin inverse and plugging my upper and lower, I just rewrote my boundaries, right? I just rewrote it. So now it's going to be 1/2 u squared is the same thing as u squared over 2. And then put in your new boundaries. Our lower boundary is 0, and our upper boundary is pi over 6. So apply fundamental. So this was going to be pi over 6 squared. Then you have this 1/2 minus 0 squared, 0. So what's pi over 6 squared times 1/2? That's pi squared. And then 6 squared is 36 times it by 1/2, which is pi squared over 72. And then this is 0, so yes, that's your final answer. There you go. Okay, let's move on to 16. So let's say we had the integral of x over 1 plus x to the 4th of dx. Let's see. What can we do? Should we use u substitution it's either going to be x or 1 plus x to the fourth, and that will not work. So let's kind of break this into two. Let's break this down or write it and rewrite this problem, and then we'll use what we know. So x over 1 plus x to the fourth can be expressed as x times 1 over 1 plus x to the fourth of dx. And then we know that the integral of 1 over 1 plus x squared dx is the same thing as tan inverse of x dx, right? So what we'll do is, we don't have an x squared. Maybe we can rewrite x to the fourth as x squared to the square. That's what I'll do. Okay, I think that's much better. Now I think what we could do next is use a u substitution, and I think I'm going to use my u as x squared, and my du is going to be 2x dx. And unfortunately, we have to get rid of this 2 because we don't have an extra 2. So what I'm going to do is multiply both sides by 1/2. So this is going to be 1/2 du, and then 1/2 times 2 is x dx. So it's going to be, okay, so we have 1 over 1, and then we said we're going to replace x squared with u. So it's going to be u squared. And then we have this x dx, and we're going to replace that with 1/2 du. Okay. Uh, what I would do is, this is a constant 1/2, so you'll put that in front of the integral. So it's going to be 1 over 1 plus u squared is u squared du. Okay, now we can replace, we know that the integration of 1 over 1 plus x squared dx is the same thing as tan inverse of x dx, but we're going to replace our x with u. So our final answer shall be 1/2, or tan inverse of u, and then this is a constant of 1/2, so bring that down, and then plus c. And then lastly, replace your u with x squared. And that's your final answer. Okay, let's move on to 17. Okay, 17, we have x over square root of 1 plus 2x, and I think we could just get away with it just using regular u substitution. So I'm going to set my u as 1 plus 2x, right? And then do the du. What's the derivative of 1 is 0, the derivative of 2x is 2. And then let's get rid of this 2 because, whoops. Yeah, look here, we kind of have a problem. Okay, you're probably thinking, well, this doesn't work because we need to have some kind of x, and we don't have an x. It will work. What we'll have to do is rewrite u in terms of x. But so first, I'm going to get rid of this 2. It's a constant. by multiplying both sides by 1/2, right? This is going to be 1/2 du equals to dx. Okay. Now I'm going to rewrite u in terms of x. So what is our u? It's 1 plus 2x. And yeah, so we said that our u is u equals 1 plus 2x. And then I'm going to solve for x. So what I'm going to do is first subtract 1 from both sides. And you get u minus 1 equals to 2x. And then divide this by 2. And you get x equals u minus 1 over 2. So what I'm going to do is replace, well, let's see, that's simplified. U minus 1 over 2, you can divide each term by 2. So this would be 1/2 u minus 1/2. Okay. And yeah, so that's what I'm going to do. I'm going to replace my x with 1/2 u minus 1/2. And then I'm going to replace 1 plus 2x with u. So yes, do you see this? I'm going to replace this x with 1/2 u minus 1/2. And then I'm going to replace 1 plus 2x with u. So this would just be square root of u. So I'm putting it in terms of u, right? And I'm going to change my boundaries because I don't want to use 0 and 4. So now, but yeah, before I do this, on the top you have a 1/2. So if I factor out a 1/2, this would be u minus 1, right? So what you could do is factor out a 1/2, and then you get u minus 1. And then on the bottom, it's square root of u. Well, I know that square root of u is the same thing as u to the 1/2 of du. And basically, you can divide each term by 1/2. I mean, each term. So what I'm doing is u1 over u to the 1/2 minus 1 over u to the 1/2, right? That's what I'm doing. And when you do all that work, and for example, over here, when you're dividing with the same base, you subtract. So what's 1 minus 1/2? 1/2, right? And then you can rewrite 1 over u to the 1/2 as a negative power as u to the negative 1/2. Okay, so when you simplify this, it should get you should get 1/2 u to the 1/2 minus 1/2 u to the negative 1/2, right? And then you have this constant of 1/2. And then you might have to change your boundaries. That's what I'm going to do because we said that I'm not going to use 0, 4. So change your boundaries. So when x equals to 0, your u is going to be 1 plus 2 times x, which is 0, which is 1. The same thing here, when x equals to 4, u equals to 1 plus 2 times 4, which is 9. So now my boundary is 9 and my upper is 1. And when you put it all together, when you put it all together, you should get 1/3 u to the 3/2 minus u to the 1/2. And then we factored out a 1/2, so that gives you 1/6 u to the 3/2 minus 1/2 u to the 1/2. And then you apply the boundaries, your upper and your lower. So, oops, I got this one. This should be 9 here and 1 there, right? It's upper minus lower. So this is 1, 9. And when you do that, you're going to get 9 to the 1/2, 6. Wait, it's 9 to the 3/2. Minus 9 to the 1/2, 2, minus bracket, and then it's going to be 1 to the 3/2 over 6 minus 1 to the 1/2 over 2. You get 1/2, and then this is going to be 1/3 times 27 minus 3 minus 1/3 plus 1, and you get 1/2. And then this is going to be 18 over 3 minus 1/3. And then 1 over 1 can be expressed as 3 over 3. And when you put it all together, you should get 10/3. Okay, that is your final answer. Okay, let's move on to number 18. So number 18, we have d over dx of the integral of x of square root of x of cosine t over t of dt. So what happens is the d over dx in the integral cancels, right? If you have a derivative, d over dx is a derivative. If you have an integral at the same time, they cancel. So yeah, that it just disappears. So what we're gonna do first is yeah, I'm gonna substitute x upper and lower. So I'm kind of gonna do like the fundamental theorem. I'm gonna substitute x by the upper and lower. So that's gonna be cosine of x over x. And then what I do is I'm gonna take the derivative of x, which is 1, and then minus the same thing, but this time I'm gonna do square root of x. So it's gonna be cosine square root of x over square root of x times the derivative of square root of x, which is 1 over 2 square root of x. Okay. And then, so what you get is cosine of x over x minus, so when you multiply this out, you're going to get cosine of square root of x. And then on the bottom, radical x times radical x is x times 2, that's 2x. And then you can, since we're subtracting fraction, you can multiply, you need an LCD, right? And you're going to have to multiply top and bottom by 2. So that's going to be 2 cosine of x minus cosine of square root of x all over 2x. Okay, and I think that's your final answer. Yes, that is your final answer. It's 2 cosine of x minus square root of radical x all over 2x. Okay, so let me kind of recap what I did. So in this one, if you have a derivative and integral, it disappears. Then what I did was I applied the upper boundary, which is x. I plugged that in, and then I kind of had to take the chain rule, basically taking the derivative of x, which is 1, and then minus, and then apply your lower boundary, which is radical x. So you get cosine or square root of x over x times the derivative of radical x. Clean that up a bit, and this is what I got. Okay, good. Let's move on to 19. So 19, we have d over dx of the integral of 2x of 3x, lower boundary 2x, upper boundary 3x plus 1, and we have sine of theta to the fourth plus 2 tan theta of d theta. So just like the other one I'm going to do is I'm going to apply so we know that this cancels. The derivative and the integral is now canceled. You're going to put the upper boundary and then times it by the derivative of 3x plus 1. Then it's going to be minus, and then you're going to apply the lower boundary, which is 2x, times it by the derivative of 2x, which is 2. That's it. So it's going to be, I'm going to say bracket sin, and then I'm going to replace my theta with the upper boundary, which is 3x plus 1, raised to the fourth, plus 2 tan of 3x plus 1, times it by the derivative of 3x plus 1, which is 3. And then I'm going to do minus bracket, and then I'm going to apply the lower boundary, which is sin of 2x to the fourth plus 2 tan of 2x times it by the derivative of 2x, which is 2. Okay, so when you clean this up, let's put the 3 in front. So this would be 3 sin of 3x plus 1 to the fourth plus 2 tan of 3x plus 1 minus 2, and then this is going to be sin of 2x to the fourth plus 2 tan of 2x. Clean it up a bit more. Clean it up a bit more, and you get this. It's going to be so now I'm going to FOIL out this 3. So it's going to be 3 sin of 3x plus 1 to the fourth plus 6 tan 3x plus 1 minus, and then I'm going to FOIL out this 2. So this is going to be negative 2 sin of 2x to the fourth minus 4 tan of 2x. Okay, so this is my final answer. Okay, let's move on to 20. Okay, 20, we have to take the arc sine of x dx. So, yikes, what are we going to do? Can we use u substitution? I don't think nothing will work for my u. Um, so I think what we'll have to do is do integration by parts. Elate. And I think I'm going to use I think I'll use u as arc sin. And then and then my dv is the leftover, which is just dx. And then with integrate, you take the u prime. So what's the derivative of arc sine, or really sine inverse of x? That's the same thing. It is going to be 1 over square root of 1 minus x squared dx. And then how to find, I got to find b by taking the integration of 1 dx, which is just x. Okay, so if you recall, the integration by parts is uv minus integration of v du. So my u is arc sine, and my v is just x, minus the integration of v du. So my v is x, and my du, or my u prime, is this. And then put it all together, you get x arc sin of x minus x times this. It's just x over square root of 1 minus x squared of dx. And then how will we do this? So this is good. There's nothing else we can do. What about the integration of x over square root of 1 minus x squared dx? Yes, you said it. Definitely u substitution. So I'm going to do u equals 1 minus x squared. And my du is going to be negative 2x dx. So I'm going to have to get rid of this negative 2 because we only have an x and a dx. So I'm going to multiply both sides by negative 1/2. I get negative 1/2 du, and then this is going to be x dx. Square root of 1 minus x squared is u. And what can we do? We can replace this x dx with a because we want it in terms of u. So yeah, we can replace this x dx with negative 1/2 du. And then you have this extra, you have a minus here, and then we can factor out this constant negative 1/2, take that out. So now you have the integration of 1 over square root of u of du. And then let's rewrite this 1 over square root of u is the same thing as u to the negative 1/2 du. And over here, you have two negatives, which is a positive. So that's going to be a plus 1/2. And then don't forget you have this x arc sine of x. Okay. And then how do you take the integration of u to the negative 1/2? It is power rule. I mean, you take the old power plus 1 divided by 1/2. cross multiply, that's 2u to the 1/2 over 1. And then 2u to the 1/2 is 2 square root of u. So I get arc x, arc sine of x plus 1/2 times it by 2 square root of u. And then we don't have any boundary, so it's plus c. And clean that up a bit. So x arc sine of x 1/2 times 2 just disappears, so you're left with square root of u plus c. And then finally, you can replace your u with 1 minus x squared. That's your final answer. Okay, let's do one more. Yeah, let's do 21. This will be our last one. So what's the integration of 0 to 2 of this thing, x cubed plus x squared minus 12x plus 1 over x squared plus x minus 12 of dx? So what you have to do is maybe we'll do partial fraction because I don't think it factors and nothing will cancel. Wait, we don't know that yet. So I think we'll have to do partial fraction. And then, but first we got to check if it can be factored, right? By doing long division. So let's do that. Let's do long division. So you get x squared plus x minus 12, and then it's going to be long division, which is x cubed plus x squared minus 12x plus 1. And I think I'm going to use I got to get rid of this x cubed, so I'm going to do it, multiply everything by x. I'm going to put it right above this negative 12x. So I get x cubed plus x squared minus 12x, and then I distribute this minus. So this cancels, and this cancels. So now you're left with the 1. So you can rewrite this as x plus your remainder, which is 1. And then you divide it by 1 divided by whatever you were dividing, which was x squared plus x minus 12. Okay, now can we integrate this? I think so. Let's break it into 2 separate integration to make it easier. So it's from 0 to 2, and then it's going to be x dx plus the integration of 0 to 2 of 1 over x squared plus x minus 12 dx. Okay, we know how to take the integration of x dx from 0 to 2, right? What about this? We can't do u substitution. We can't do u substitution, right? We can't factor in, nothing will cancel. You're going to have to do partial fraction. So let's do this because this one's easy. We can do that later. So how to set this partial fraction, you're going to set it up as 1 over x squared plus x minus 12 equals actually let's re x squared plus x minus 12 can be factored out as 1 over x minus 3 times x plus 4. and that equals to a over x minus 3 plus b over x plus 4. And then let's try to get rid of the bottom by multiplying everything by the LCD, which is basically x minus 3 and x plus 4. Oops. And then FOIL this out, this cancels as 1. And then over here, when you multiply this by this term, the x minus 3 cancels. So you're left with a and x plus 4. And then when you multiply this by this term, the x plus 4 cancels. You're left with b and x minus 3, right? Okay. So this is what we get. And then maybe if we set x to 3, something will cancel and we can just find one of our letters. So let's do that. So it's 1 equals a, and then replace x with 3. So it's going to be 3 plus 4 plus b, and then 3 minus 3. And then 4 plus 3 is 7. 4 plus 3 is 7, so it's 7a. And then 3 minus 3 is 0. So the b's cancels. Now solve for a, so you're going to divide this by 7. So a is 1/7. Let me box that. Now, what about b? So if we go back to here, and we know that a is 1/7, how can we solve for b? Yeah, plug in another value for b. So, I mean, for x. So maybe we can do x equals, I don't know, -4. Okay, so it's going to be 1 equals a, and then replace x with -4. So that's -4 plus 4 plus b, and then -4 minus 3. And then this cancels 0, 0. -4 minus 3 is plus 6, -7. B. I get 1 equals -7b. So divide this by -7. And I get b equals -1/7. Okay, now we can start doing our problems because we found our a, we found our b. So a is 1/7. So we're gonna just replace a with positive 1/7, and then we're gonna replace b with, what would I say b was? -1/7. So this is going to be the integral 0 to of x dx plus the integration of 0 to 2, and then we're going to replace a with 1/7 of x minus 3 dx plus the integration from 0 to 2, and then replace my b with -1/7 over x plus 4 dx. And then I'm going to, 1/7 is a constant, so you can put that in front. So you get 1 over x minus 3 dx plus, and then -1/7 is a constant, so that take that out. 0 to 2, and then you have 1 over x plus 4 dx. And let's do this real quick. What's the integration 1 over x minus 3? You'll have to do u substitution, which is x minus 3, and then take the du, which is 1. So that works out real nice. So that's going to be from 0 to 2. 1 over x minus 3 is u yeah, 1 over u dx. And then what's the integration 1 over u ln of u? Or actually, what we could do is like change the boundaries. So if u is x minus 3, and then if one of our x is 2, so it's going to be u equals 2 minus 3, which is -1. And then up to the lower boundary, so it's going to be 0 minus 3, which is -3. So we can rewrite this as -3 to the -1, 1 over u du. And the integration of 1 over u is ln of u from -3 to -1. Let's see here, the same thing here. This would be ln of absolute value of -1 minus ln of absolute value of -3. Absolute value of -1 is 1 minus ln of -3. Which is really 0. ln of 1 is 0. And then over here, my u is going to be x plus 4. And my du is 1 dx. So it's going to be from 0 to 2. Or you can change your boundaries if you like. So if u is Rx is 2, oh, it's going to be, we can use -3 to -1. And then it's going to be 1 over x plus 4. And we know that's going to be, so you can write this as -3, -1, 1 over u. And we know the integration of 1 over u is just ln of u from the boundaries -3 to -1. So when you put it all together, including this, I didn't do this part, I should have done that. That's easy. What's the integral of x? It's 1/2 x squared. And you can just do 0 to 2. You don't have to change the boundaries. So 2 squared is 4 over 2. That's 2 minus 0, just 2. So when you put it all together, you should get 2 2 plus, so you should get 2. When you do all the work, you should get 2 plus 1/7 ln of 1 minus 1/7 ln of 3 minus 1/7 ln of 6 plus 1/7 ln of 4. You get 2 minus 1/7 of ln of 3 plus ln of 6 minus ln of 4. And you get 2 minus 1/7 ln of 18, because when you're multiplying, you're adding, right? Minus ln of 4. So you get 2 minus 1/7 ln. And when you're dividing with the same log, you're dividing, right? So this would be 18 over 4. You get 2 minus 1/7 ln of 9 over 2. Your final answer is 2 plus 1/7 ln of 2 over 9. Okay, so that's the last one for this. Then there will be a part 3 and part 4, etc. Allow me to stop here.